The future of naval warfare is no longer a distant concept sitting inside classified design rooms or science fiction movies. It is already taking shape in the form of the U.S. Navy's Next Generation Destroyer program, widely known as the DDGX. Planned as the eventual successor to both the aging Ticonderoga-class cruisers and parts of the legendary Arleigh-Burke destroyer fleet, this warship is being designed for a completely different era of combat. An era defined by hypersonic missiles, drone swarms, electronic warfare, cyber attacks, and increasingly contested oceans. And while the Navy has not yet finalized every detail of the vessel, what we already know paints the picture of one of the most ambitious surface combatants the United States has ever attempted to build. At first glance, the DDGX looks like a ship pulled straight from the future. The hull design borrows some of the stealth-shaping philosophy seen on the Zumwalt-class destroyer, with smoother angles and reduced radar reflections intended to make the ship harder to detect at long range. Unlike older destroyers that were built during an era where sheer firepower often mattered more than survivability against advanced sensors, this new vessel is being designed with signature reduction as a core feature from day one. That means lower radar visibility, reduced acoustic noise underwater, and even efforts to minimize infrared signatures that enemy targeting systems could lock onto. In simple terms, the ship is being engineered not just to fight harder, but to hide smarter. But stealth is only one part of the story. What really separates the DDGX from current destroyers is its enormous growth potential. One of the biggest problems facing modern warships is that technology evolves faster than ships do. A destroyer built today may remain in service for 40 years or more, yet weapons and sensors change dramatically every decade. The Navy learned this lesson with the Arleigh-Burke class destroyers, which became increasingly difficult to upgrade because of limited space, cooling, and electrical capacity. DDGX is meant to solve that issue entirely by building in massive reserves of power and internal volume from the beginning. This is where the ship's integrated power system becomes incredibly important. Instead of using traditional propulsion layouts that mainly distribute power mechanically, the DDGX is expected to use an advanced integrated electric power architecture similar in concept to the Zumwalt class. That may sound technical, but the practical advantage is huge. The ship can redirect electrical power wherever it is needed most, whether that means propulsion, radar systems, electronic warfare equipment, or future weapons that demand extraordinary amounts of energy. This matters because the Navy is preparing for a future where lasers and potentially even electromagnetic weapons become standard equipment. Conventional destroyers simply do not generate enough power to support those systems efficiently, but DDGX is being built with that future in mind. And speaking of weapons, the DDGX is expected to carry a devastating arsenal. Early concepts suggest the ship will feature around 96 vertical launch system cells as a baseline configuration, similar to some current destroyers, but with the ability to support much larger missile cells in the future. That flexibility is critical because next-generation hypersonic missiles are significantly larger than many existing naval weapons. Instead of designing a ship around current missiles alone, the Navy wants DDGX to remain adaptable for decades. This means the destroyer could eventually deploy a mix of standard air defense interceptors, long-range strike missiles, anti-ship weapons, ballistic missile defense interceptors, and hypersonic systems capable of traveling at extreme speeds. For viewers unfamiliar with naval combat, imagine a floating missile fortress capable of defending an entire fleet while simultaneously launching attacks hundreds or even thousands of miles away. That is essentially the role DDGX is expected to fill. Modern destroyers are no longer just escort ships, they are multi-role combat platforms operating as command centers, missile defense shields, intelligence hubs, and offensive strike assets all at once. Another major feature expected on the destroyer is an upgraded version of the SPY-6 radar system already found on Flight 3 Arleigh-Burke destroyers. The SPY-6 is considered one of the most advanced naval radar systems ever developed, capable of tracking ballistic missiles, aircraft, drones, and surface threats simultaneously. But DDGX is expected to push this even further by offering additional room, power, and cooling for larger radar arrays and future sensor packages. In practical terms, the destroyer could potentially detect and engage threats earlier, more accurately, and under more complex battlefield conditions than any previous U.S. Navy surface combatant. And this is increasingly important because the threat environment at sea is changing rapidly. Potential adversaries are investing heavily in anti-ship ballistic missiles, long-range cruise missiles, unmanned systems, and electronic warfare. The Pacific theater, in particular, presents enormous challenges due to the vast distances involved and the sophisticated anti-access strategies being developed by rival naval powers. DDGX is being designed specifically to survive and fight inside these highly dangerous contested zones. One of the most interesting aspects of the program is that the Navy appears determined to avoid repeating some of the mistakes associated with previous advanced warship projects. The Zumwalt-class destroyer, for example, introduced groundbreaking technology but suffered from rising costs and changing mission requirements. The littoral combat ship program faced criticism over survivability and design compromises. With DDGX, the Navy is trying to take a more evolutionary approach rather than a revolutionary one. Instead of building an entirely experimental vessel from scratch, the program combines proven systems from existing ships with carefully selected next-generation technologies. In other words, the Navy wants innovation without excessive risk. That philosophy is visible in the ship's expected combat systems. Many elements of the current Aegis combat system architecture will likely carry over into DDGX, ensuring interoperability with the broader fleet while reducing developmental uncertainty. Sailors already familiar with current systems may also transition more easily to the new platform. This practical approach may not sound as dramatic as creating a completely futuristic warship overnight, but in military procurement, reliability often matters more than flashy concepts. The physical size of the destroyer is also expected to increase significantly compared to current Arleigh-Burke-class ships. Estimates suggest a displacement approaching around 14,000 tons or more, placing it much closer to cruiser territory than traditional destroyers. That extra size is not just about carrying more weapons. It also improves endurance, stability, fuel efficiency, and long-term upgrade flexibility. The ship is expected to remain deployed longer, travel farther with less logistical support, and sustain higher operational readiness in demanding environments. Crew survivability and automation are also expected to play major roles in the design. Modern naval warfare moves incredibly fast, and crews are often overloaded with information during combat scenarios. DDGX is likely to incorporate higher levels of automation to reduce workload and improve operational efficiency. Advanced battle management systems could help sailors process threats more rapidly while allowing the ship to respond to multiple attacks at once. Automation may also reduce maintenance demands and potentially lower crew sizes compared to older warships, though survivability standards remain extremely high. Another fascinating aspect is the destroyer's potential role as a command and control platform. As the Navy retires older Ticonderoga-class cruisers, there is growing concern about maintaining fleet-level command capabilities. DDGX may effectively inherit part of that responsibility, serving as a central node within carrier strike groups or distributed naval formations. That means the ship will not only fight enemies directly but also coordinate broader operations involving aircraft, submarines, drones, satellites, and allied forces. The vessel's design philosophy also reflects a broader shift in naval doctrine. For decades, naval power focused heavily on carrier strike groups dominating open oceans with relatively limited peer competition. Today, the strategic environment is far more dangerous. Adversaries